Welcome to the Builders Academics Online tutorial. Thanks for watching our YouTube videos online. Please, if you have not yet subscribed to this YouTube channel, do well to press the subscribe button and the notification bell in order to see all of our educative videos online. Please remember to share this video with your friends, families, and relatives. Please let us know whether this video helped you by dropping your comment. Thank you and God bless you. Amen. Today we are going to be considering nomenclature of organic compound. Nomenclature of organic compound. We are talking about nomenclature of organic compounds. It's a very, very essential topic in chemistry. And talking about nomenclature of organic compound, we have common name and we have Iupac name. Common name and what? Iupac name. We have two types of nomenclature in organic compound. We have what? The Iupac and the what? And the common name. The Iupac name is the acceptable what? Name. That's why we call it International Union Pure and Applied Chemistry what? Naming of what? Naming system of organic compound. The Iupac system of naming is the most acceptable what? Is the acceptable way of naming any what? Organic what? Compound. Iupac system of naming or nomenclature is what we are going to be talking about today. So we have the common name of organic compound and we have what? The Iupac system of naming of what? Organic compound. Now, I'm talking about the common name. When we hear about isobutane, neopropane, paraffins, alcohol, these are common names. For instance, now when we hear about paraffin, we use paraffin. We use olefin for all these type of what? Hydrocarbon, alkane and alkenes. So we use that common name for them, and we use isopropane, isobutane for naming them. These are falls under what? Common name. But today we are going to be considering the Iupac name, which is the International Union of Pure and Applied Chemistry system of what? Of naming. Iupac nomenclature. The Iupac nomenclature, the first thing you need to know is what? You have something called what? The Iupac nomenclature has what? Three principles. You have to know three things in any organic compound before you can name it using what? Iupac what? Nomenclature. The first thing is the parent name. The parent name of the organic compound. The parent name of the organic compound, which is the what? The main functional group. The main functional group. You can have more than two functional groups in a what? In a compound. But the main functional group will be the what? The parent name. While others will be the what? The substituent. So really that you need to understand what we call what? Functional what? Functional group. I will just try to do the recap on what we mean by functional what? Group. This is an identity. It's an identity of what? Of a particular organic what? Compound. And we have several functional groups in organic compound, which we have highlighted in the previous in one of the videos I did on what? On November, December Waec what? Chemistry. So now, but today I will just quickly rush into what the functional group is all about. Now you need to know the what? The substituent present in the what? The substituent present. So I will still talk about that. The substituent that you are having. They have different type of substituents. And lastly, you have to know how to what? How to number, the numbering of what? Of a functional group of an organic compound. It has the method of numbering. For example, now if I want to number what? A particular functional group where the substitute lie on, I must be able to number it very well. You need to know how to number. Numbering is very, 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 very important. Numbering and the alphabetical order. How to use the word? The alphabetical order in what? In placing your substituents. So that the numbering and the alphabetical order of the word of the substituent is very, very, very what? Important. These are things that you need to consider under what? Substituent. So the alphabetical order and the numbering of the substituent is very, very, very what? essential. Now let's quickly go to what? The functional group that we are having in what? In organic chemistry. I will just first one now here, this first column is the functional what? The functional group. The functional group. The general formula for the functional group. The general formula for the functional what? The general formula for the functional group. And then the what? The type of bond that is present. The bond. The type of bond that is present. The type of bond. Let's call the type of bond. And example of that what? The example of the what? Of the compound. So we are using two types here. So for example now when you have what? The first one is alkane. Alkane is what? Is a saturated what? Hydrocarbon. So the alkane general formula is what? CnH2n plus what? 2. CnH2n plus 2. The type of bond here that is present here is what? Is C double bond. That is single what? Single bond. C single bond. That is single what? It has single what? Single bond. An example of such what? Compound is when you put 1 into this one, when n equals 1, this one will be C1. 2 times 1 will give you what? 2 plus 2, it will give you what? C4. An example is what? Methane. You call this one methane. Number 1 is methane. We are still coming to the numbering. So the methane, we have methane. So for the alkane group, the general group is CnH2n plus 2. And the what? And the type of bond present is what? Single bond. Now the second one is what? Alkene. Alkene, we have CnH2n. Then the type of bond is C double bond. So C double bond, you have this is a double bond compound. A double bond compound. This is a double bond compound. And then example of this one starts from what? N equal to 2. This one starts from N equal to 1. N equal to 1 and so on and so forth. When N equal to what? This one starts from N equal to 1. 1, 2, 3 and so on and so forth. But when you're talking about alkene, the N starts from what? The N, let me put it here. The N starts from 1, 2, 3 and so on and so forth. But when you're talking about what? The alkene, the N starts from 2, 3, 4 and so on and so forth. So now you put 2 here now. What do we have? We have C2. 2 times 2, this one goes C2H4. So we have 18. So this one starts from number 2, and number 2 is what? Is 18. So that's that about that one. So next one is what? Alkyne. Alkyne is the third. This is the third functional group that we have. It is CnH2n minus what? 2. Minus 2. This has 3 what? Bonds. This has 3 bonds. We call it triple what? Triple bond. We call it triple bond. And triple bond is also the end start from what? 2 here. From 2, 3, 4 and so on and so forth. So an example is when you put 2 inside this place, what do we have? We have C2. 2 times 2, we have what? 4 minus 2. To give you weight, 2 times 2, that is what? 4. 4 minus 2, it will give you what? 2. So this is what? C2H2. So this is what? This is ethane. We call it what? Ethane. The name, the type of bond, the example, and what? And the name. So ethane and so on and so forth. Now the next one is alkyl. Alkyl is usually a substituent. Alkyl is usually a substituent. Alkyl, CnH2n plus 1. It is when alkyl is obtained when one hydrogen is removed from an alkane group. You can see you remove 1. So when you remove 1 from this what? When you remove 1 hydrogen from this compound called alkane, you are going to have CnH2n plus 1. So it will give you alkyl group. So an alkyl group starts from number 1, 2, 3 and so on and so forth. So an example is also a carbon-carbon single bond. Now an example is melty, which is C1, put 1 is C1, 2 times 1, it will give you 2 plus 1, it will be C1H3. We call this one methyl. It's an alkyl group. Methyl. And now after you have what? This 4, this 1, 2, 3, 4. They fall into a group called hydrocarbon. You can call this one hydrocarbon group. This from here to here is an hydrocarbon group. From here to here is an hydrocarbon group. This is called hydrocarbon organic compound. We call it hydrocarbon group or hydrocarbon organic compound. It only contains hydrogen and carbon. Now, when you now start from here, now next one that we have here is arcanol. So when I talk about arcanol, we are having Cn, H2n plus 1 OH. This alkyl group can be written as R, so ROH. So an alkyl group plus what? OH will give us arcanol. And the common name of arcanol is alcohol. This is the word, the Iupac, but this is Iupac name, but the common name is alcohol. We always give we generalize the word, the common name as alcohol, but the Iupac name is what? Arcanol. So the general formula for arcanol is CnH2n plus 2 CnH2n plus 1 OH, ROH. The first one, and this one also starts from what? This one starts from number 1 because you have methanol. It starts from N is equal to number 1, 2, 3, and so on and so forth. So when you put 1 here, you have what? C, and you put 1 here, this one gives what? C1, 2 times 1 is 2, plus 1, CH3, OH. So this is called methanol. So we call methanol. So this one, how do I get that? Met is 1. So with the functional group now, the no here you put it, met is 1. Then no is the what? Is the functional, is the name of the functional group for the word arcanol. So we just put no there. So another functional group that we have after what? Arcanol is called arcana. We have arcana. The common name for arcana is called aldehyde. Now note that the common name for alkane is called paraffins. We call it paraffins. This one is olefins. They are called olefins. The double word they are called what? Olefins. This alkyl group, we call them, the alkyl group is substituent. We call them isobutyl. We have what? Isobutyl. We have arcanol. This one is also called alcohol group. This one is called aldehyde for the common name. The common name is one part. I put the common name inside the bracket. You can see the word, the paraffins, the olefins, the what? The alcohol, the aldehyde. So the arcana has the general formula of CnH2n plus 1 CHO. N equal to what? 0. When n equal to 0, you are going to have C0, H what? 2 into bracket what? 0 plus 1 CHO. This one will give you what? This one is 0 now. We don't have anything here. But 2 times 0 here will give you 0 plus 1. It means H, 1H, CHO. So we call this one methanol. So the what? The N here starts from what? 0. Please note that the N of what? Of this group arcana starts from what? From 0, 0, 1, 2, 3. We have what? That's why we have methanol here. Another one is what? Is arcanone. Arcanone as what? Ketone. Ketone has general formula of CnH2n plus 1, then CO, then you still have another one here, CnH2n plus 1. So meaning that it has RCO, R prime, or you can call it another R. So Cn H2n plus 1, Cn H2n plus 1. You can call this one RCHO because R represents what? Alkyl group. So this one has CO in between. It has CO in between R. CO in between R and this first alkyl, this is the second one. Okay, now let's start from here now. Back. So the remaining type of functional group here, we have the functional group, the general name, and what? The type of bond. Don't forget that this is coming from here. They are coming from here. So we have what? The functional what? The functional group, the general formula, and what? And the type of bond that we have, the type of what? The type of bond that we're having. Now, the functional group now, after the alkanol, we have what we call alkanoic acid. Alkanoic acid. Also known as what? Carboxylic what? The carboxylic. Also known as what? The common name is carboxylic acid. The carboxylic acid, and the general formula of Cn H2n plus what? Plus 1 COOH. Now, this is also known as what? RCOOH. If you want to write the what? The bond present, the type of bond present, and the example. The type of bond present to be RC. This C will take double bond O. This one is what? O, then OH. Now, this is C double bond O and OH. It means it has what? Ketone and what? Hydroxyl group. That's ketone. And hydroxyl, that is what I will come about carboxylic acid, COOH. So type of bond that is there is C double bond O, single bond what? OH. So an example is methanoic acid. When you put what? N, when N is equal to 0, 1, 2, 3, and so on and so forth. When you put 0 inside this formula, and I'm going to have C is going to be 0, but 2 times 0 is going to give you 0 plus 1. This one will be H. It will be H, COOH. So this is called methanoic acid. Methanoic, because you are putting 0, we call it methanoic acid. So now it has only one carbon, methanoic acid. Methanoic acid. So now the next one is what? The next one is alkanoate. Alkanoate is known as X-stars what group? They are the group of organic compound that has sweet what? Sweet smell. And general formula for alkanoate is what? Cn H2n plus 1 COO, Cn H2n plus 1. So it has RCOO R prime. So if I want to write it down here, I'm going to write R single bond C double bond O CO R. So that's that. How to write it? C double bond R C double bond O single bond O and then R prime. So now an example is when you put N is equal to what? 0. What are we going to have? If put N equals 0, we are going to have H here. H equals to N. It means that sometimes, do you know why we are having R prime, R N? It means that this alkyl group might be different from what? Each other. Now, for example, now I can have what? Methanoate. How to write methanoate? You will read it from the back. The methyl will be at the back, then COO, then H. COO, methanoate, H. So this is methanoate. So methanoate. So this is an example. This is the simplest example of what we can have in what? In alkanoate what? Compound. And also we also have a amines and what? Amines. Amines has the general formula of CnH2n plus 1 NH what? 2. NH2. We have amines. So we have primary amines, secondary amines. This is the word primary amine, but it usually what asks this. You can just write as what RNH2. They have amine and we have the last one amide. I'm just giving you so that you should be aware that we still have another what set of what another groups of what organic compound called amines and what amide. They usually ask about the reaction or names the word Iupac name in most cases. So now we have the word the amide has what RONH what 2. It means that it has carbonyl, it has what it has carbonyl and what NH2. So if I want to write this one now, it will just be RNH. But this one we have what RC double bond O N H NH. So that's how to write the bond. So these are just the what all the functional group that we have in organic chemistry. And now we're going to how can we use this functional group to name the given what compound before us. Now the first question says the name of the organic compound CH3. Now we are having solutions to this to these first questions. The name of the organic what compound CH3. The organic compound equal to what CH3. C into bracket what CH3 brackets 2 CH2 CH2 CH what 3. Now this is the given compound. This is the given compound, and we are asked to name the organic compound. Now look at this. This organic compound is in condensed form. Now the what? The compound, the carbon and hydrogen are what? Are condensed. They are fixed together. They are what? They are closely packed together. So we call it the condensed form or the condensed molecular what? Formula of the compound. You can see they are together. Now we have to what? If you have to name this compound, you are to what? Write it in a branch form to get what? To be able to what? Comprehend it better. So maybe I'm going to rewrite this condensed structure of this organic compound in a branch what? In a branch what? Or in a Keku structure form. A Keku structure form is what? The branch form of writing what? Of writing organic compound. Now how do I write it now? This one will now become, look at this, CH3, this C, it has what? CH, this C contains CH3 in two places, meaning that it's one is on the top, one is on the back. So we have what are the words? CH3, then it has another one, CH2, CH what? Don't forget there's a bond also here. So this is a Keku form of what? Writing what? The Keku way of writing what? Of writing any organic compound in branch form. So now, with this now, I can now easily what? Name it. Now, and if I want to name this compound, I need to know my substituent. I need to know, I need to know my substituent, I need to know my parent's name, and I need to what? Number it in accordance to the what? To how small or least they are. Now, how do I like that? Now, if I want to name this compound, now the first thing I need to consider is the what? The parent name. What is the parent name? What is the parent name? The what? What is the parent name? The substituent present. I need to note that the substituent present and the numbering of what? The numbering and what? And the naming of the substituent is very, very important. The naming of the what? Substituent. Now, let's consider this theory in this compound. Let's consider this theory of this compound. Now, the parent name of this compound, what will be the parent name of this compound? If you can see very well, they all have single bond. If you check the table I gave to you, whenever you're having single bond, all two in a compound, the parent name will be alkane. So this group is an alkane what? This organic compound belongs to an alkane group because it has only what? Single bond or two. Now you now count the what? number of what carbon that is present here. Which one is the highest what? The first thing is to know the longest chain of what of this organic compound. If I count like this, 1, 2, 3, 4, 5. This is the longest chain. 1, 2, 3, 4, 5. This is what 5. 1, 2, 3, 4, 5. This is also another way of counting it. 1, 2, 3, 4, 5. So if I whichever way I want to count, if I count it straight like this, it is 5. If I count it like this, it is 5. If I count it like this, also what? 5. So why can't I use what? I will just use the straight chain. So the straight chain I will contain what? 1, 2, 3, 4, 5. So the highest, the number of carbon that this straight chain contains now is what? Is 5. And we are talking about the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 is met. Now 2 is earth. 3 is probe. 4 is boots. 5 is what? Is bent. 6 is X. 7 is X. 8 is out. 9 is none or nonna. Now we have what? Then 10 is what? 9 is none. Then 10 is deck. Now the 5 here is what? Pent. Now because it belongs to what? Archangel, the parent chain will be what? The parent name will be pentane. Because it belongs to Archane. Archane has A-N-E. So I will now go back to what? Where I have what? Pent. I will now add A-N-E. So the parent name for this word, the parent name for this compound is what? Is pentane. I'm having pentane. So the parent name is pentane. Now, the substituent here, I'm having substituent which I write what? In what? In a green color. This is what? We have substituent CH3 here. Now, and how do I name this substituent? This substituent you can see is a methyl what? It's a methyl substituent because it contains only one carbon. So methyl and it has H3. So now this is methyl. Now, how do I number the substituent? The numbering is very, very important. If I number from the back, now the substituent we have the substituent will fall to which position? Let's count 1, 2, 3, 4. The substituent will fall on number 4. If I count from the back, for example, now this is 1, 2, 3, 4. So it means this one is going to have 4. If I count from the back, the substituent is going to have 4, 4. Because the substituent here, the substituent, if I count from the back, 1, 2, 3, 4. So my substituent is going to have 4. So I must always count in such a way that my substituent will have the least number of what? Numbering. Now if I count from the back, it's going to have 1, 2, 3, 4. But let's count from the front. From the front now, it has what? From the front, it has 1, 2. So if I count from the front, I have 2. If I count from the back, my substituent will have what? 4. 1, 2, 3, 4. So this one is wrong. This one is wrong, but this one is right. So I'm going to start from counting from here. So 1, 2. 1, 2. So my substituent will fall on number 2 now. So because it is 2 methyl that fall on this what? On this carbon now, it is 2 methyl that fall on this carbon. And I'm going to say, okay, my substituent is 2, 2. Now the first methyl will take 2, the second methyl also will take 2. Now I'm having how many 2 now? Because it's 2 methyl now, it's not say dimethyl. Now remember, you also know another thing that we use whenever we have the same substituent repeating itself. Whenever a substituent repeats itself twice, we have di. When it repeats itself thrice, we have tri. When it repeats itself what? 4 times, we have tetra. We have this one, we have di is 2. Tri is what? Is 3. Tetra is what? 4. And that's the what? The highest that we usually have here. So now we have di, tri. If we have more than that, we have penta. So, but it's usually what the maximum usually have is what? Tetra. So now here we have what? 2, 2. Now the name of the substituent is methyl. So we have di because it is 2. Dimethyl. Now dimethyl. Now what's the parent name? Don't forget pentane. Pentane. The parent name is what? Let me change this. color. Pentane. So 2,2-dimethylpentane. That is the what? Is the Iupac name for this what? For this compound. 2,2-dimethylpentane. You can see the parent name here is 1, 2, 3, 4, 5. Pentane. Then the substituent itself falls on the carbon 2. On carbon 2 when you count from the front, which is the least numbering. So that's why I have 2,2-dimethyl. You can see this 2,2-dimethylpentane. So the option is what? The option is 2,2-dimethylpentane. The option is number what? The D aspect. So please note that the D. So that's that number 1. Question number 2. Now question number 2 says that the Iupac name of the compound represented by the structure given. Now look at this structure given to us. We have C double bond C, single bond C. Then we have substituent what? The substituent of chloro. Then we have double bond C. Now here is the question given to us. Now we are asked to name this organic compound now. Look at this very, very well. Now we have the what? We have the functional group of what? The functional group of this compound here. The functional group of this compound here, as you can see, it contains double bond. So whenever a compound, organic compound contains double bond, the functional group that organic compound belongs to is alkene group, because it belongs to it. So this functional group of the alkene group here, the functional group of the alkene here is what? The functional group of this what? Organic compound is alkene. Then, if it is alkene, what name? What will be the parent name? Now the parent name depends on what? On the number of carbon we have here, 1, 2, 3, 4. So the number or the parent name will depend on the number of carbon that is 1, 2, 3, 4, which is but. So it is butene. It's going to be what? Butene. But not only butene, because we have 2 double bonds here. We have 2 double bonds, which is what? Diene. Each double bond is what? E. So we are going to have diene. So it means that we are going to have diene because it has what? 2 double bonds. Now, what will be the position of the first E and the second E? Now, if you count from the back, this one is going to be 1, 2, 3, 4. The first carbon that has connection with what? E here, this bond, double bond here, is carbon 1. And the second one here is what? Carbon what? 3 has connection with this what? This E also. Now, if you name it from also and from the back, what do we have? We are going to have 1, 2, 3, then what? 4. You can see the first one. The first one here has what? The first carbon here has connection with what? The first double bond here. And the third carbon one has the connection with what? The what? The double bond also. But now which way should we what? Should we name this organic compound? Which way? Should we name this organic compound? Which way? Now the first, what we determine whether you want to name from the back or you name from the front is this substituent. Look at this substituent. The substituent, or you name it from the back, the substituent here fall on number what? Or number 2. Even though the what? The parent name, which is the double bond, falls in 1 and 3 from the what? From the back. It falls or what? 1 and 3 from the front. It's also fall in 1 and 3 because this double bond has connection with this is 1 and also has connection with this is what? 3. So whether you count from the front or you count from the back, the double bond still have what? Boots 1, 3, diene. Because the first double bond is number 1 and the second one is on number what? Number 3. When you check it from the back, when you check it from the front, it's also number 1 and number 3. But now, which way are we going to name our substituent? Now look at this. When you come from the front here, the substituent chloro, you call it chloro because it's an halogen group. An halogen group, when an halogen group become a substituent, halogen group are elements on what? On group 7, such as chlorine, fluorine, iodine, and what? And fluorine, chlorine, iodine, and we have one chlorine, fluorine, iodine, and fluorine, chlorine, iodine, and we have astatine, and so on and so forth. Chlorine belongs to what? Group 7 on the periodic table called halogen, and they are referred to halo when they become substituent in an organic compound. So now, halo are group 7 words, elements. We call them halogen. But when they are in substituent, we call them what? Halo. An example of them are what? Chloro, fluoro, fluoro, iodo, bromo. So astato, that's what they are starting. Astato, but we don't usually see. So now chloro, fluoro, iodo, and what? Bromo. Now this one now, chloro, which is the what? Substituent. We now count in such a way that you have the list. If you count from here 1, 2, your what? Your chloro will be on number 2. So the name of this compound will now be what? 2 now. We know the parent name. The parent name is what? Is what? Is buta 1,2-diene. Then the substituent name is what? Is chloro. But the numbering of that, the number at which what? Chloro will have the least numbering. The position at which chloro will have the least numbering is position what? 2. So it means that the substituent now will now be 2 chloro. 2 chloro. So when you join together, the name of the organic compound now, the Iupac name of the organic compound now, the Iupac name of the organic compound now will now be what? 2 chloro boots 1,3-diene. So 2 chloro what? 2 chloro boots 1,3-diene. You combine this and this together. So what we have as our final answer? 2 chloro boots 1,3-diene. Option 1. 2 chloro boots 1,3-diene. That is option number what? Option number A, which is A. Option A. So that's that about what? About that. Please note the fact that you have to consider what? The word E is the word, is the functional group, which is what? Boot. E. But it has to double, you have to state the position of these 2 double. So boots 1, 2-diene. That's the parent name. Now we now come to what? The what? To the substituent, which is the chloro, and you number it in such a way that the chloro will have the least numbering. So, and when you number from the front, the chloro will be number 3. When you number from the back, so this is what I mean by from the what? When you number from the back, the number from the back. That's you are numbering from the back 1. Now when you are numbering from the front, you are going to have 1, 2, 3. But when you are numbering from the back, you are going to have 1, 2. So the chlorine will fall in number 1 or number 2, which is very, very important. So that's why I have 2 chloro, because it's the least compared to 3, 2 chloro. Now combining this together, I have 2 chloro with 1,3-diene. So that's that. Please, if you don't understand, make sure you drop your comment so as to know where to come in the next tutorial video. It's next video tutorial. Please, if you are not getting it, make sure you drop your comments below so as to know where I will come in, or I will give more clarity when I'm going to do the next video. Now that's that. Number what? Number 3. Number 3, we're going to say that the structure of the 6th member of alkenes. The sixth members of alkenes. The six members, they write the structure of the six members of alkenes. Now the first thing you need to ask yourself, alkenes, which hydrocarbon is alkenes? Which hydrocarbon is alkene? Now this is double bond hydrocarbon, So you see that that's the functional group of alkenes and the functional group of what? CnH2n, and it contains what? Double what? It contains double bond. Alkenes contain double what? Bond. You have to do that. Now, if the now says 6, it means that n is equal to what? 6. So we have 6 C6 H2 bracket 6. So we have C6 H12. So we have to write the structure for C6 H12. And how do you write structure for C6 H12? Now we draw what? C. Now is it up to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So for alkenes now you can put, it's better you put the double bond on the first one so that it will be what? It will be X1E. Because X1E is same as Xzine. So it's better you put it, but if you put it in the what? Maybe it will be X2 in, X3 what in. It will be an isomers, but if you put it at number 1, it will just be Xzine or X1, and X1 is same as Xzine. So now feed the rest. Now we have what? Let's try and feed this. So this one has already have double bond. We have 1 H 1, 2, 3, 4. So this one is complete. We put 1 H here. Put H here. Now let's write it. Now let's write it is complete. How many carbon are there? 1, 2, 3, 4, 5, 6. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is called X1E. Because the position of what? Of E here is number 1, which is equivalent to what? Xe. If they say she write it as what? So X1 is written as what? It's equal to what? Xe. So you can also what? When you put this relation to this one, it's now become X2 it's not an isomers. We are going to talk about isomers later in what? In the subsequent 4. The Iupac name of the what? Of the compound CH2OH. This another compound here. If I want to write it in the form of a split form, the branch form, whereby I'll be able to see the number of carbon and the number of functional groups clearly. Now how do we write it? We have CH what? We have CH2 here. Look at it very well. How many carbon? 1, 2. So this one belongs to X. And the functional group here we have the major functional group here. The main functional group here is what? The main functional group here is your functional group. This is just a substituent. OH is considered to be what? The substituent. The functional group. I list the functional group for you, which is what? Which is alkane, alkyne, alkene, and so on and so forth. Alkene itself is not even a functional group, but rather a substituent. It's also what? It has a functional group of what? CnH2n plus 1, but it's usually a substituent. These two functional groups, which is what? Alkene and what? allo group. Allo, note that allo and alkyl group are substituents. They are substituents. Note that allo and what? Alkyl group are substituents. Allo group are chloro, fluoro, bromo, and so on and so forth. And alkyl group are LT, propene, and so on and so forth. They are all substituents. Now this is the major functional group, which is hydroxyl group, which is known as alkanol. Alkanol now 1, 2. How many carbon do we have? We have 2 carbon. So this is ethanol. This is ethanol because it comes from what? Earth is what? Number 2 carbon. Then the OH here has the functional group of alkanol. Alkanol has a name of the hydroxyl group as what? As the other name of no. So we are going to put, because it is carbon, earth. Now we are going to what? Ethanol. 2 carbon, earth plus what? Plus O. It gives what? Ethanol. So this is ethanol as the what? As the parent name. And then you start counting to know the position of your substituent. 1, 2. So now the chlorine is attached to number what? 2. So we have 2 chloroethanol, 2 chloroethanol, 2 chloroethanol, 2 chloroethanol. You can join it here. 2 chloro, no spacing, 2 chloroethanol. So 2 chloroethanol is also what? 2 chloroethanol. 2 chloroethanol is number what? D. 2 chloroethanol is D. So that's that about that. The general formula of alloalkenes, where X represents what the halide is what? The general formula of what? Alloalkenes, where X is what? Is halide. Now, for example, the general formula for what? Alloalkenes, where X is what? Halide. Now the first thing you need to ask yourself, what are halides? Halides are what? Halides are hydrogen. We have hydrogen halides, we have hydrogen chloride. Halides are hydrogen and what? An halogen group. Halide is as a result of hydrogen and what? Hydrogen and halogen what? Halogen group. That is group what? 7. Halide is a result of hydrogen and what? Hydrogen and halogen group. And halogen group is represented as what? As X, e.g. chloro, fluoro, iodine, bromo. These are the major words one that we use. So now halide group can be written as what? HX, when X can be chloro, fluoro, iodine, and bromo. Now when the general formula of alloalkenes, where X represents hydrogen what? Halide. Hydrogen halide. For example, now when you have now what? When you now add what? When you now add alkenes now. When you add HX to alkenes. When you add hydrogen halide to alkenes, what do you have? What you have is this. This hydrogen will join this one. It will become what? Hydrogen will join this will what? 2H plus 1. This hydrogen will join this. It will do what? It will now give you what? So it will give you what? Please note this. Then it will give you, let me draw it like this. It will give you what? CnH2n plus 1. Now this hydrogen will have it will now be H2n plus 1. Then it means the S is now attached to this. So this is what? CnH2n plus 1. This hydrogen will join one hydrogen with 2 is what? CnH2n plus 1. That X will now be beside it. So the option is what? Option B, what? D. Note that this is what? Halide is Hs, hydrogen and what? Halogen will form halide. So halide plus what? Plus alkenes. Halide plus alkenes. Plus halide plus alkene. It gives what? Haloalkene. Haloalkene. Because this one is not one word. So we do haloalkene. So haloalkene or haloalkene. Whichever you want to call it. Okay, so now look at this. Question number what? 6. We are asked what? We are asked to name this organic what? Compound. We are asked to name this organic compound. Please look at this question. We are asked to name this is C. Look at this compound. I have to name this compound. I have to name this compound now. If you are to name this compound, how do we name it? Now, see, this is the major functional group here. Because the HO is the major functional group. This one is substituent. These are substituents. This is major functional group. So whenever you have CHO, now whenever you have what? HO, this is an alcohol group. Alcohol group. This is an alcohol group. It's connected to what? This what? It's connected to what? So this is the functional. This is a functional OH. OH. If I count 1, 2, 3, 4. This is butanol. That's my parent name is what? Butanol. Because OH is what? Alkanol. So butanol. Now you have to start numbering from where the functional group is here. Because you want the functional group will always take number 1, 2, 3, 4. So now the first substituent here is chloro. The second one is what? Bromo. Now between now we have bromo and chloro to be our substituent. Now bromo alphabetically B comes before C. So you give priority to what? To B. So this one will now be what? 3 bromo. Because 3, this bromo is number 3. 2 chloro butanol. 3 bromo, 2 chloro butanol. So the answer is what? 3 bromo. If you have 3 bromo, 2 chloro butanol, that's the answer. So that is that about that. Number 7, it says you give what? Structure for what? 2 methyl what? Give structure for what? Structure for right, structure for number 7. Structure for 2 methyl but 2 in. 2 methyl but 2 in. Now, the first thing is to first draw the parent chain, which is but what? But 2 in. C, but is 4. Now, number 2, the 1, 2, the 2, the carbon will form the double bond on the carbon 2, 1, 2, 1, 2. So that's what we call what? But 2 in. Then 2 methyl butene. So you can put it here, you can count 1, 2 here and put methyl here. So that is that. So we have what? You can complete this with what? H, H, H. 1, 2, 3, 4. Now this one is already complete 1, 2, 3, 4. This one is just put 1 H to it. Make it complete 1, 2, 3, 4. Then you put what? H, H, H. So that's that about that. So this is 2 methyl. You can see 2 methyl boots 2 in. So that's that about what? That. So now let's name this number 4, and this is the last question here. Question number 8, which is the last question here. Let's do this one. Question number 8. How do we do it? Question number 8. Question number 8. How do we? Now question number 8. It says what? The Iupac nomenclature for this structure above is what? Now the first thing is to note that this one contains functional group of what? Of what? It's alkene. Functional group here is alkene. And the what? And the parent name will be what? Let's count it. 1, 2, 3, 4. So it will be 4. That is boots. Boots. Am I correct? Let's count. 1, 2, 3, 4, 5. 5. Is this the longest chain? No, it's not the longest chain. 1, 2, 3, 4, 5, 6. You count like this. This is the longest chain. This is the longest chain. So this is another way of see. You have to look for the longest chain. This is the longest chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's the longest chain. Now this one is 5. But when you go like this will be the longest chain. So if this one be the longest chain, 1, 2, 3, 4, 5, 6. So this one is what? X, because it's number 6. And the position of the third one is 1, 2. We are going to have X 2 in 1, 2. The position of what? Of that one is what? 2. So X 2 in. Now let's look at the substituents. What are the what? What are the substituents that are attached to this relational chain? We have methyl. Methyl is a substituent. Methyl is a substituent. It's a substituent. That is substituent 1. And also chloro is also a substituent. So chloro and what? And methyl are what? Are substituent. And they are 2, 2. They are both 2. 2 what? Chloro, 2 methyl. 2 chloro, 2 methyl. So this is dimethyl. But what is the position? If I start counting because of the position of this one, let's start counting. This is number 1, 2, 3, 4. Meaning that chloro 4 and number 2 and what? 3. It falls on number 2 and 3. So if I want to name this now, know that my parent name is this. My substituent name. Now let me just write it here. So my parent name now, my substituent here is what? The first substituent here is chloro and methyl. They are both di. This one is 1, 2 di. This one is 1, 2 di. So we have di. The substituent we have dichloro. We have 2, 2 dichloro. Sorry, it's not 2, 2. 2, 3. 2, 3 dichloro. 2, 3 dichloro. Let me write it down. The substituent I have here, the first substituent is 2, 3. 2, 3 dichloro. Why am I writing dichloro for? So I know dimethyl because chloro alphabetically it comes before what? Dimethyl, because this dimethyl falls on what? On 4. This is 4 for dimethyl. So dimethyl falls on what? On 4, 4. But between methyl and chloro, carbon comes before what? Before methyl. So because chloro comes, C comes before what? Methyl. C comes before M. Alphabetically, C comes before F. Alphabetically, this is why I like this dichloro first, is because C comes before what? F. So that's why. So if I want to write it combined together now, so the whole naming is going to be what? 2,3-dichloro. So the answer here is here. 2, let me write here. 2,3-dichloro. 4,4-dimethyl X2 2,3-dichloro 4,4-dimethyl X2. We have the answer here. 2,3-dichloro 2,3-dichloro 4,4-dimethyl hexene. So that is the answer number 1. So that's that about that. So option D. So we have come to the end of today's class. Please, if you have any question or would like the videos, please do it to comment below and subscribe to this YouTube channel. Let us know your comments and your questions and your challenges. We love you all. Please keep watching Builders Academy tutorial and keep on sharing the videos with others. Goodbye and God bless you.